All right, we've made it to the end of this chapter, Chapter 9, Lesson 7, which is independent and dependent events. And an independent event is one event that is not affected by the outcome of another event. And that's kind of a hard definition to really understand, but if we kind of use an example of that, hopefully it will make more sense. If you were going to toss two coins, tossing the first coin doesn't affect how the second coin lands. Now, it does affect the probability of those things occurring together, one after the other. So you're going to notice that they're not just, I hear the word independent and I almost think that like one doesn't affect the other. It doesn't affect it as far as how it lands, but wanting two things to occur simultaneously is going to be a decreased probability, less likely to occur than if we just wanted one thing. Right? It's obviously easier for me to flip a coin and it land on heads than for me to flip a coin and it land on heads 5 times in a row. Even though the probability of each of those things individually is the same, having them to occur one after the other is not the same. So you'll notice in both of the definitions here, we see multiplications. We are going to multiply, but dependent events are different in that the outcome of the first event affects the second one. Well, how can this be? Well, if you take the example here, it talks about a bag of fruit. And if we're going to pull 2 pieces of fruit out, after I pull the first piece of fruit out, there's now less in the bag. There could be less of what I'm trying to achieve in that second pull, but there's going to be less fruit altogether. So you're going to see in our fractions here with dependent events that the numerator and the denominator are going to decrease. That doesn't happen with an independent event. All right, so we'll get into some examples and hopefully that'll make a little bit more sense. This is where we're talking about an independent event. A game requires players to roll 2 number cubes to move the game pieces. The faces of the cubes are labeled 1 through 6. What is the probability of rolling a 2 or a 4? So we notice here that we have 2 numbers that we're trying to get. Just think about a dice. It has a 2 on one side, it has a 4 on one side. So those are the 2 options that we're looking to get out of the 6 total options that exist on the dice. So the probability of the first part there would be 2 out of 6, because that's just talking about getting one of these 2 numbers. It's not 1 out of 6 because there's 2 different numbers that we want to get. Then we are going to we're going to roll the second cube, and we want to roll a 5. Well, 5 is only 1 out of my 6 options, right? It's only one side of that dice. So this was 2 sides of the dice. This is one side of the dice. And then to have those occur together, we would want to multiply that. And so you would get 2 over 36. And as always with probability, we need to reduce that into lowest terms. So this becomes 1, and then I need to cut 36 in half, which would be 18. So I have a 1 in 18 chance of getting these 2 things to occur. Remember, like I said, there's going to be multiplication in every problem because we want 2 things to occur. So even though we would call this an independent event, the probability is kind of not really independent. How this second one is affected by the first one, it's unaffected. It is independent. But because we're wanting those to occur together, there does have to be multiplication. All right. So moving on, go back into presentation mode here. And you can see there's that answer of 1 over 18. Now, 2 examples on this slide, and these are going to be the last 2 examples that I'm going to share with you. So it says there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Joe selects a piece of fruit at random, and then Megan selects a piece of fruit at random. So notice those exist in the same basket. So whenever Joe selects fruit, he is affecting what is left in the bag for Megan to choose, right? If he pulls out an orange, there's now 1 less orange in the bag, but there's also just less fruit in the bag altogether. So that changes her probability. So when the second one is affected by the first one, this is when it is a dependent event. So we're looking to get 2 bananas. So first we have to figure out the total that exists when we have these together. So we need to total up all of the fruit that exists in the problem. So we have 4 and 7 and 5. We're going to add all those up together. That's going to give me 16. So there are 16 pieces of fruit. And we're after 2 bananas. Well, whenever Joe gets ready to pull, there are 7 bananas and there are 16 pieces of fruit. So if he pulls that out and gets a banana, then we are going to notice that there's going to be now only 6 bananas in there, and there's only going to be 15 pieces of fruit because he pulled what he wanted. We're not really concerned what happens if he doesn't get that. We're only figuring out the probability of getting 2 bananas. So there's the probability of getting 1 banana, and then her probability is going to be slightly different because there's 1 less banana and there's 1 less a piece of fruit. And then we have to multiply those 2 together. So you're going to get 42 in the top, and then we have 16 times 15, and I'm reaching for my calculator here. That's 240, and then that's going to need reduced. So one of the easiest way to reduce this would be just to cut those in half. So that would be 21, and this would be 120. But then I also know that this goes into 3, and this goes into 3 as well. So this is going to be 7 over 40. All right, so the next one, to get an orange, then an apple. So now we're going to start out again with 16 pieces of fruit. And there are 4 oranges. And if Joe pulls out, so that's his probability of getting this. We know we're going to multiply. So my next fraction, if he pulls out an orange, there is 1 less piece of fruit, right? There's 15, just as there was in this example up here. There were 15 here as well. But now, when it comes to getting an apple, this number is not going to be 3, it's going to be 5. Now, why did it decrease here and not decrease here? It actually went up. Well, remember, he wants an orange followed by an apple. Well, there would still be 5 apples left in the bag if he is able to pull out an orange on his first pull. And so we're going to multiply those together. So we would end up getting 20. And then I already have that same denominator. 16 times 15 is 240. And then we need to reduce that one as well. So I'm just going to go ahead and move on to the last slide so you can see those answers. So we got 7 over 40, and then we said it was 20 over 240. And then you'll notice that I just kind of, I divided those both by 10, since they both end in a 0, and get 2 over 24. And then that still can be reduced to 1/12. So these are both examples of dependent events, because when something is located in a bag together or a deck of cards and you want to pull one card followed by another one, that matters. But if it's 2 separate items, spinning one spinner and then spinning a separate spinner altogether, or even spinning the same spinner, as I spin it once, I'm not affected by anything because the spinner would look identical on that second spin. So that's kind of the difference between independent and dependent events. Again, watch the video, look at the Google form. There will be a Zoom that we have for you to kind of tune into if you need help on the homework. But this is going to wrap it up for the chapter. This is the last lesson. Be careful on your fractions here. Make sure you are reducing. And this will do it for the chapter. Thanks.